Despite its unusual appearance, the American tank became the technological foundation for the Soviet BT series and significantly influenced the history of armored warfare. The events of 1918 changed the way military experts around the world viewed the strategy of future wars. These heavy machines proved they could break through defense lines and barbed wire in sectors where the infantry was suffering heavy casualties with zero tactical success. The United States, eager to catch up with European nations militarily, was looking for engineers to build a powerful tank force. They found the designer they needed in an ordinary auto repair shop in New Jersey, where he was already drafting designs for machines that, decades later, would shape the course of World War II. John Walter Christie was born in 1865 and showed a keen interest in mechanics from an early age. Even as a child, he explored how various devices worked, taking apart and reassembling pocket watches and sewing machines. By the time he was 30, Christie was already running his own machine shop and designing race cars, earning a steady income during the auto industry's boom years. His cars stood out for their unconventional technical solutions, and the designer himself gained a reputation as a man who ignored accepted standards and did things his own way. This uncompromising nature would later determine both his professional successes and the difficulties in his career. When America entered World War I, Christie saw the potential for large-scale military contracts. He understood that the government would be allocating significant funds for armaments and decided to offer his designs. Starting in 1918, the engineer began regularly approaching the War Department with projects for self-propelled artillery and armored vehicles. Military officials were initially skeptical of the auto mechanics blueprints, but Christie proved to be incredibly persuasive and persistent. He kept reaching out to leadership, sending letters and schematics, and pushing for personal meetings. By 1919, those efforts paid off. The American Army, realizing they were technologically lagging behind European powers in armored warfare, signed a contract with the inventor to develop a new battle tank. They were banking on a machine that could rival British and French designs, but the result was significantly different from their expectations. Christie worked intensely, barely ever leaving the workshop, and forged numerous experimental ideas into metal all at once, trying to make the most of this opportunity. In the fall of 1919, the finished prototype rolled out of the factory gates. Designated the M1919, the tank had a specific design that looked atypical for the engineering solutions of the time. Two turrets were stacked in tiers on a squat, angular hull. In the lower main turret, the designer mounted a 57mm gun, while a smaller turret with a machine gun sat above it. Both modules rotated independently, giving the combat vehicle a rather unusual appearance. The project's main feature wasn't the turrets. Walter Christie wanted to solve the problem of slow-moving tracked vehicles. On paved roads, the tank rolled on large wheels located at the corners of the hull, 2 on each side. The crew could remove the tracks and strap them to the armor, allowing the vehicle to move like a wheeled armored car. When terrain conditions worsened, the tracks were reinstalled, giving the machine back its full tank capabilities. This concept was ahead of its time, but the technical execution had some flaws. The vehicle weighed in at 13.5 tons, double the standard for light tanks of that era. The 120 horsepower 6-cylinder engine struggled to handle the load. On wheels, the tank reached speeds of up to 12 miles per hour, and on tracks, only 7. The 3-man crew was stationed inside in rather cramped conditions. By 1920, The Aberdeen Proving Ground in Maryland had become the central hub where the future of American armor was decided. Prototypes were brought here to test their compliance with Army requirements, weeding out the ineffective models. When Christie's design arrived at the Proving Ground, officers and engineers gathered to inspect the new machine they had been hearing about. The appearance of the M1919, with its tall, two-tiered turret structure, sparked keen interest among those present. Military experts carefully studied the prototype and discussed its characteristics. The designer himself showed confidence that the trials would succeed and fully expected his project to go into mass production. The very first tests showed a disconnect between expectations and the machine's actual capabilities. As soon as the tank started moving, specialists spotted serious flaws in the suspension system. The four massive wheels at the corners of the hull were connected almost directly to it without any effective shock absorption. A single bogie in the middle, with a pair of small rollers, failed to improve the situation. While the vehicle remained relatively stable on flat surfaces, driving onto a dirt road revealed critical problems. The tank shook violently. Every bump in the terrain was transferred to the hull as heavy jolts and loud noise. The crew couldn't stay in their seats, which made aiming impossible, and accurate fire while on the move was out of the question entirely. Outside observers noted significant swaying of the turret, while the tankers were forced to periodically open the hatches for fresh air due to motion sickness. By that time, coil spring suspension was already becoming the industry standard, offering a reasonably smooth ride over rough terrain. However, Christie refused to use proven solutions, preferring his own design vision instead. The test results were unsatisfactory. In their reports, military experts were critical of the vehicle's driving performance, deeming it unacceptable for combat conditions. Suspension issues were just the beginning of the list of flaws. The 120 horsepower engine, which Christie had borrowed from the automotive industry, simply couldn't handle the weight of the armored machine. On inclines, the tank crawled. The engine was overworked and spewed out thick smoke. Several times the vehicle ground to a halt right on the test track, forcing the crew to climb out and repair the engine compartment while the observers watched. Off-road performance proved so poor that officers questioned the tank's ability to participate in actual operations. The mechanized units the Army planned to create required equipment capable of quickly crossing any terrain and maintaining the overall pace of an advance. Christie's design fell far short of the stated goals. The system for switching between wheels and tracks drew particular scrutiny. A solution that seemed effective in theory required a significant amount of time and effort in practice. The crew had to leave the vehicle, manually remove the heavy tracks, secure them to the hull, and then do it all in reverse when the road surface changed. In the heat of real combat, such a lengthy procedure would have put the crew in critical danger. The two-tiered turret design also drew negative reviews. While the concept of two independently rotating turrets allowed for simultaneous fire in different directions, in reality, the tank commander couldn't effectively coordinate the gunner and the machine gunner, as they were in different compartments and had no visual contact with one another. Instead of improving combat effectiveness, the previous design solution only complicated operations and created inconveniences for the crew. However, the military saw some potential in this project. The convertible suspension concept itself looked promising, and the 57mm gun demonstrated significant firepower for a vehicle of its class. Army Command decided not to stop cooperating with Christie and made a new decision. The inventor received additional funding to develop an improved version of the tank. He embraced this opportunity with enthusiasm, not foreseeing that realizing this second chance would face even greater difficulties. With the contract in hand, the designer focused on his work in the shop, intending to address all the military's concerns. He understood the importance of this stage for his career and worked with increased intensity. The production process went on without a break, and by 1922, the workshop presented a new model designated the M1921. At first glance, the machine looked much more advanced than its predecessor. Christie took the criticism into account and installed spring elements on the front wheels, which were supposed to significantly improve the ride quality. The hull took on a more streamlined shape. The interior was rearranged for better ergonomics, and the power plant underwent a series of upgrades. The convertible suspension remained a signature feature of the design, allowing the vehicle to move on both tracks and wheels. However, observers noted the absence of a familiar element, the turret. Instead of the massive two-tier superstructure installed on the previous model, the new chassis was left open. The armament was mounted directly in the front hull plate, making the tank resemble armored vehicles from the start of World War I. This design choice caused quite a surprise among military experts, considering it was already 1922. By then, the rotating turret had become the accepted standard in tank building, as it allowed fire in any direction without having to turn the vehicle's hull. The French Renault FT-17, with its classic layout, had already solidified its status as the benchmark for engineers around the world. Yet Christie's project, lacking a turret, essentially returned to the concepts of a previous era. When the inventor was asked about his motives, he explained that he aimed to reduce weight, simplify the design, and increase mechanical reliability. According to the designer, eliminating the turret saved weight, which was then used to reinforce the armor and running gear. The military men listened in silence, but the looks on their faces betrayed obvious skepticism. Tests of the M1921 began with cautious optimism. The spring suspension on the front wheels actually did improve the ride quality a bit, so the crew felt much more stable while on the move. The interior ergonomics had also improved. Mechanics had easier access to the components, and the driver had a more comfortable station. It seemed like Christie had finally taken his past mistakes into account. However, the issue with the underpowered engine hadn't gone away. The tank still struggled under heavy loads on inclines and showed mediocre dynamic performance. The transmission's reliability remained poor. Mechanisms broke down frequently, forcing the testers to stop the trials and fix the machine right there in the field. The military meticulously recorded every breakdown, and the list of defects grew rapidly. But the main problem turned out to be the lack of a turret. By that time, Army tacticians had already formed a doctrine for tank warfare, where the ability to react instantly to threats from any direction played a key role. A turretless machine had to turn its entire hull to aim the gun at a target, wasting time and exposing its flanks to enemy fire. In real combat conditions, this created a critical vulnerability. Trials dragged on month after month, stretching out for 2 years in total. The military gave Christie time for refinements, expecting the critical flaws to be fixed. The designer shuttled between the proving ground and the workshop, making numerous changes. yet he never managed to eliminate the fundamental problems. By July 1924, the command's patience had run out, and the military commission delivered its final verdict. The M1921 tank was deemed unfit for service. Insufficient power, poor reliability, and the lack of a turret brought the project to a halt. The customers cancelled Christie's contract, cut off funding, and shipped both prototypes off to remote storage. For many, this would have meant the end of a career, as Christie's reputation among the American military had taken a serious hit, and his cooperation with the Defense Department effectively came to an end. Despite the failure, the developer kept working. While Army officials considered the matter closed, Christie began designing a fundamentally new structure, one that would eventually change the way the world built tanks. He spent the years following the Aberdeen trials, thoroughly analyzing his mistakes and developing a different approach to chassis design. The engineer concluded that a flawed suspension was the reason his previous models had failed. So he focused all his efforts on solving that specific problem. The work involved dozens of blueprints, calculations, and experiments with shock absorption. Then, in the late 1920s, came the technological breakthrough. Christie developed a suspension system that earned its place in the history of armored warfare forever. The design principle was simple and effective. Each large-diameter road wheel was attached to the hull by an individual arm connected to a powerful coil spring mounted vertically inside the body. This setup provided significant suspension travel, allowing the tank to move rapidly over rough terrain, far outpacing other machines of the era. By 1928, Christie had built a new prototype incorporating these advancements. It was an entirely new machine, substantially different from the bulky models of the early 20s. The tank featured a low-profile, streamlined hull, a powerful engine, and a suspension that gave the vehicle incredible mobility. The designer kept the convertible drive, but improved the mechanism, allowing for a reliable switch between wheels and tracks. The test results showed impressive performance. The tank reached speeds of up to 43 miles per hour on wheels and 25 miles on tracks. The machine cleared ditches, climbed hills, and moved confidently across cratered fields. Journalists at the demonstration dubbed the prototype a flying tank. Christie was counting on commercial success and approached the American military again, believing the new machine was a convincing argument for a contract. However, the Army command reacted coolly to the proposal. Remembering the failed projects from earlier in the decade, the generals showed no initiative to renew cooperation with the inventor. The military's bureaucratic procedures involved lengthy approvals and inspections, while Christie had no intention of waiting for these drawn-out processes to finish. The negotiations dragged on, and the designer was gradually losing hope of any successful cooperation with his own government. Christie couldn't accept the stance of the American military leadership, which kept buying foreign models while ignoring the potential of his designs. These disagreements drove the inventor to look for clients abroad. That was the moment representatives from the Soviet Union took the initiative. The country needed to modernize its fleet of military vehicles and had the financial resources to pay for it. Soviet engineers, keeping a close watch on global tank-building trends, had taken note of Christie's suspension design. They analyzed the test results and technical specs, concluding that his proposed solutions were highly effective. The two sides established initial contact in strict secrecy. The Soviet delegation worked through intermediaries and commercial entities to avoid the attention of American intelligence agencies. For Christie, the priority was simply getting the funding and seeing his inventions put to practical use, regardless of the final buyer. Since the US government restricted arms exports, the inventor got around the ban by listing the tanks in the paperwork as agricultural tractors. In 1930, the parties finally sealed the deal. 2 Christie tanks, dismantled and packed into wooden crates, were shipped across the ocean to the Soviet Union. Along with the hardware, the buyers received a full set of technical blueprints and a manufacturing license. The designer got paid for the deal, seeing his vision through, despite opposition from US military command. When the cargo was unpacked at the factory, the engineers were impressed by the technical quality of the samples. They were looking at a machine that was miles ahead of any existing counterparts. The suspension was reliable, the design was sophisticated, and its speed far exceeded standard limits. Specialists immediately went to work studying the American design and adapting it to their own production capabilities. They intended to use this platform to develop a new generation of vehicles. The designers had received not just a tank, but an engineering concept to be reimagined and refined. The original American machine was a high performer, but it had been designed primarily for demonstrations and setting records, not for the realities of combat. The engineers took a pragmatic approach, knowing the difference between test track trials and operating under enemy fire. Work began at the Kharkiv locomotive factory, where a team of specialists took the prototype apart and examined every component in detail, calculating the stress loads. The Christie suspension was effective, but it needed significant upgrades for mass production. The American inventor had designed the vehicle to be hand-built one by one, while the industry needed machines suitable for the assembly line. In 1931, the first Soviet tank based on an American design appeared, the BT-2. The abbreviation stood for High Speed Tank. The vehicle kept the original suspension and wheel and track drive, but it was fitted with a new turret housing a 45mm cannon, reinforced armor, and a locally built engine. Engineers used the American prototype to create a full-fledged combat machine. Field trials confirmed its superior performance. The BT-2 moved rapidly across the proving ground, clearing obstacles and showing off a level of maneuverability that set it apart from other tanks of the era. Military leadership approved the test results and immediately ordered mass production. The Kharkiv factory shifted to a round-the-clock schedule, rolling out dozens of machines every month. Designers continued to refine the technology, and in the following years, new modifications with improved specs appeared. The BT-5 got a more powerful engine and an upgraded transmission. The BT-7 marked the final stage of the series development. It featured a welded hull, a new turret, and a diesel engine that reduced the risk of fire. These tanks formed the backbone of the Soviet armored forces and became a significant factor for potential adversaries. The American developer, Christie, watched the success of his design from afar with mixed feelings. On one hand, his ideas had gained recognition and were embodied in thousands of combat units. On the other, it didn't happen in his homeland, but in a country that the American press of the time called the enemy of civilization. The inventor continued pitching his designs to the US Army, but faced bureaucratic roadblocks and a lack of interest from officials. Meanwhile, Soviet engineers continued to develop the technology. Operational experience with the BT tanks proved that Christie's convertible drive was practically unnecessary. Crews almost never removed the tracks, preferring their versatility over the speed offered by wheels. Designers took this into account and abandoned the wheel drive in future developments, but they kept the suspension scheme. This led to the emergence of a tank that would eventually gain widespread fame. A bureau led by Mikhail Koshkin created a new machine based on the BT series. A reinforced Christie suspension was carried over almost unchanged, while engineers designed the rest of the components from scratch to meet the demands of war. Sloped armor, a cannon, a diesel engine, and high mobility were combined in a single hull. The tank was designated the T-34 and became the most mass-produced in history. Over the war years, factories turned out more than 50,000 units, and the ideas of the American inventor were preserved in every one of them. Thanks to the Christie suspension system, T-34 tanks could confidently tackle rough terrain in areas where enemy equipment often got stuck. This made it possible to bypass fortified positions and launch strikes from unexpected directions, which became one of the key advantages of this armor. History took an unpredictable turn. Designs that were initially rejected in the United States as unpromising later transformed into a weapon that significantly influenced the course of world events. Early prototypes with complex designs and multi-tiered turrets evolved into the high-speed machines of the BT series, and those in turn became the foundation for the T-34. In every single vehicle that utilized this chassis in combat, the engineering ideas of the designer from New Jersey effectively continued to work. His technical solutions and his drive to create the fastest possible machines found their direct embodiment in these vehicles, forever changing the approach to tank building of that era.